Welcome to an introduction of number systems. This topic is part of a larger learning outcome where we would hope that you'd be able to convert between number systems. So to do that, of course, you need to understand what the basics of number systems are. Modern number systems are what are called positional. That is, the value of the digit depends on its place in the number. So for decimal, our decimal number system, we might have a number like 359, and what that really means is that we've got the 300s, 5 tens, 9 units. So the place of the 3, the 5 and the 9 is very important because it depends what the multiplier would be. So, oops, don't want things like that in recording. So what we have is 3 hundreds, 5 times 10 plus 9 times 1. The 10 is the base as used by our decimal number system. Now each number system also has what's called a digit set, that is, what are the elements or symbols in that set, and they're usually 0 up to the base value minus 1. So for decimal we have the digits or symbols 0 to 9. And this digit set is really equivalent to saying what are the possible remainders when dividing by the base. So of course when you divide a number by 10 you can't get anything else other than 0 to 9 as a remainder, because if you did then it would be divisible by 10. So you can't have a remainder of 12. Each value must be unique. In other number systems, binary for example, that's base 2, the digit set is 0 and 1. That is, when you divide a number by 2, you can only get 0 or 1 as the remainder. 0 for even numbers, 1 if it's odd. For other number systems like hexadecimal, which is to base 16, of course you can get 11, 12, 13 as a remainder, but you can't write 1, 3 as a remainder because that's then confusing with, say, the 1 and the 3 for 13. So instead of 1, 3, we represent 13 as a D. So A is 10, 11, 12, 13, 14, 15 for F. To give you an example of non-positional number systems, you'd recognise the Roman numerals. We don't use Roman numerals for arithmetic because they're not positional, and this example shows why that's the case. So if we're trying to add numbers like 8 plus 7 in arithmetic, we end up with this strange effect where the original numbers have more places, more digits than the final answer, which we don't have in decimal in our modern number system. So if you're interested in more about number systems, there's a good online course at Virginia Tech. So I'll see you in the class. We'll continue on.